Hello everyone, I am Prem Kumar. Welcome to Math J Academy. So today I am going to discuss with you a very interesting problem. So before going to the problem, so if you not yet subscribe my channel Math J Academy, please subscribe it. So you can, who are watching the channel, so who are parents or students, please you can see the all the contents in my channel. This completely step by step explanation is there. Just to sit at a few minutes, you can learn everything perfectly. So some students may think, why SR is posting only DPPs, right? Sometimes, right? No, not like that. So it will come all the chapters, because I'm focusing. First you can see the set we focused and the modulus we focused, and then logarithm, exponential, and then you can see the greatest integer function, fractional part functions. So first we have to understand all the type of functions, and then we'll start the second chapter, quadratic equations, and then complex number and sequence and series, like that. The sequence of videos will be there. Okay, so in the meantime I will post you some of the some of the students 12th standard, they experience all the chapters in 11th standards. For them this DPP will help them, right, to understand how to tackle the problems. Is there any way to approach solve within the time, right? Okay, so for that purpose I'm creating this DPP. So who are not yet subscribe it, please subscribe my channel. Thank you. Here, let us get started the problem. Let mn be the number of points at which the functions maximum of x, x cube, x power 5, x power 21. So x belongs to real number, is not differentiable and not continuous respectively. Then m plus n they're asking. You can see, observe that the maximum of, you can see how to find out this intersection here. You can see there are 21, right? So power 21 is there, all our odd power is there. You can see 1, 3, 5, 7, 9, so on, 21 is there, right? Okay, so you can observe that x cube minus x equal to 0. Then if you take x common, x square minus 1 equal to 0. Either x is equal to 0 or x square minus 1 equal to 0. Clear? So therefore x square is equal to 1, x equal to plus r minus 1. Clear? Okay. So we found that where these two curves are intersecting, it's the mostly plus 1, minus 1 and 0, right? So the whole real number, you have to break this interval into less than minus 1 and minus 1 to 0 and 0 to, you can see 0 to 1 and more than 1, you have to divide it. Okay, so let us take the first one. If x is less than minus 1, you can see all are odd powers, right? When you take negative number, for example, if I take x is equal to minus 2, right? So you can see minus 2 is the first one, and then minus 2 whole cube is what? Minus 8, so on, right? Minus 2 whole power 21. Clear? You can see when there is a larger in the negative, you can see that is your smallest, right, or biggest. Which is the smallest? For example, minus 1 and minus 2. More than that 1, right? Minus 2 is what? Less than the minus 1. So among this, which is the maximum here? Minus 2, minus 8. When the negative number is larger and larger, the value is smaller, right? Okay, so therefore the maximum of x, x cube, x power 5 and x power 21. So you can take the maximum here is x. That here you can see minus 2 is the maximum. You can compare minus 2 and then minus 8. You can see, let me take another color, minus 2 here, then minus 8 somewhat here, So which is the larger? The larger will be minus 2. So the maximum of this interval, maximum of x cube x power 5 up to x power 21 is equal to x. Clear? Okay. So let me check the another interval. So another interval is what? Minus 0 to 1. And then the second case, minus 1 less than x less than 0. In this interval, which is the maximum here? The maximum of x, x cube, x power 5, so on, x power 21. Let us take x is equal to minus 0.5, that is minus 1 by 2. Clear? Whole cube minus 1 by 2 whole power 5, so on, minus 1 by 2 whole power 21. So among this, which is the maximum you can see? So minus 1 by 2, minus 1 by 8, minus 1 by, you can see 2 power 4 is 16 minus 32, right? So on, minus 1 by 2 power 21. Clear? Is it clear or not? Okay. So in this case, what we can do, which is the maximum here? You can see the minus 1 by 2 here. So 1 by 2 per 1 very closest to 0, right? Right? This is very closest to 0. So very closest to 0 is the maximum among all the negative numbers, right? So therefore the maximum of x, x cube, x power 5, so on, x power 21 is equal to, we can take x power 21, right? This is the maximum of all the things, right? Very closest to 0 among all the negative number from minus 1 to 0. Clear? Let me check another case. 0 to 1 you can take. Okay, 0 to 1, you can see the maximum will be, let us take x, you can take 1 by 2. Let us take easy number 1 by 2. So maximum of x, x power 3, x power 3, x power 5, so on, x power 25, you can 21, right? 21. So maximum here is what? Let us take 1 by 2, 1 by 8, you can see 1 by 2, and then you can see 1 by 8, 2 cube is 1 by 8, 1 by 2 power 5, that is 32, so on. When the larger and denominator and larger, the value will be very smaller, right? Correct? So 1 by 2 is bigger or 1 by 8 bigger? 1 by 2 is the bigger, because 1 by 8, when larger and larger denominator, the value will be very small. So therefore, so 1 by 2 power, you can say 1 by 2 whole power 21, right? So among this, which is the maximum here? So 1 by 2. So therefore, if you generalize, the maximum of this will be the maximum of x, x cube, x power 5, so on, x power 21 will be x power, x only maximum, right? X only the maximum. 1 by 2 is the maximum. Clear? Let me take another interval. What is another interval? Fourth one, x is greater than 1. If I take x is more than 1, let us take 1.5. Let us take 3 by 2, 1.5. So let us take here, so 3 by 2 you can take 3 by 2. So 3 by 2 whole cube, 3 by 2 whole cube, 3 by 2 whole power 5. Clear? So on, right? Is it correct or not? Yes, correct. So 3 by 2 whole power 21. Among this, which is the maximum here? You can see simple logic. 3 by 2 is 1.5, right? is a 1.5 you are multiplying 3 times. Here 1.5 you are multiplying 21 times. The same number you are multiplying number of time is more. That is the maximum, right? Clear? Okay, therefore the maximum of x, x power 3, x power 5, so on, x power 21 would be, what is that? X power 21. Okay, I hope everyone understand, right? Okay, so you have to redefine the functions, right? How to redefine? Suppose f of x you can consider if x is less than 1 minus 1, which is the maximum here? X is the maximum, right? When x is less than minus 1. Okay, x is the maximum. When x is minus 1 to 0, if I take x, when 0 to 1 you can take, the maximum will be again x. Clear? 0 to 1 is, which is the maximum? X, right? When you take x is more than or equal to 1, x power 21 again. This is your redefined functions. Then how to check the continuous, right? You can see this is your polynomial functions, right? So variable is x, x power 21, x power 21 is there. So you can see when x is less than minus 1, it's a straight line, y is equal to x. When you take minus 1 to 0, that is x power 21, 0 to 1 will be the same again x. When x is more than or equal to 1, that is 21. So how to check the continuous? Is there any breaking is there? You can check the breaking point here is minus 1, right? And 0 and 1, right? You have to check minus 1. Limit x goes to minus minus 1 minus means what? Left limit you have to check. Left limit means the minus 1 less than minus 1, right? That will be x if you substitute minus 1. If I check right limit, minus 1 plus you can take, that will be, so minus 1 plus if you take, so that will be x to the power 21. If I put minus 1 to the power 21, again it's odd power, it's minus 1. Okay, so it's a continuous. What is the continuous definition? What is the continuous definition? Limit should be equal, and then equal to which point you are checking the continuous, that value of that point equal to those things, right? Okay, so you can check at x equal to minus 1 also, minus 1 only. So we can say that left hand limit is equal, right hand limit is equal to f at minus 1. Okay, the same way you can check at 0, limit x goes to 0 plus. 0 plus means more than 0. More than 0 means x, 0, you have to choose this function. So it will be 0. If I take x 0 minus, you can take 0 minus means less than 0. So x power 21, that is also 0. But f at 0 you can check it. So that is also 0. Therefore here left hand limit is equal to right hand limit is equal to f at 0. Therefore continuous, right? Let us check at 1. So limit x goes to 1 plus you take. 1 plus means more than 1. That is x power 21. Right? Correct? And that will be 1. So limit x goes to 1 minus you can take. 1 minus less than 1 means what? So less than 1 means x. Here is also 1. Okay? And f at 1 you can calculate. That will be 1 only. Therefore, left hand limit is equal to right hand limit is equal to f of 1. Therefore, the function is continuous everywhere. So, therefore, what is the n here is given to you? So, n is, what's n? N is the number of points is not continuous. Therefore, n here is what? 0. Right? N is 0. N is equal to 0. Why? Because the function is continuous everywhere. n is given to you the number of points not continuous. So therefore n equal to 0. Clear? The next thing you have to check the differentiability. Differentiability means you can use direct derivative, f dash of x formula method you can apply. Otherwise, you can differentiate the function. You have to check left hand derivative is equal to right hand derivative. Both are equal means the function is differentiable at the point. Suppose you can calculate this. F dash of x you calculate quickly. What is that? 1 if you x differentiation 1, right? And then if x is less than minus 1. So if you differentiate x power 21, x to the power 21 minus 1, right? Correct? X to the power n differentiation, right? Okay. If x is minus 1 to 0, when you take in 1, if x is 0 to 1, when x is more than 1, the differentiation is again 21 x to the power 21 minus 1 is what? 20. So here also you can write 21 into x to the power 20 you can write. Okay, fine. Now you can easily verify this. Left hand limit you can see, left hand derivative you can check it. Left hand derivative. What is the left hand derivative? Minus 1. So f dash of minus 1 minus you can check it. What is that? Limit x goes to minus 1 minus is what? Which function you have to take? 1. It's 1. But when you take f dash of minus 1 plus you take limit x goes to minus 1 plus will be, what is plus? It is 21 x to the power 20. So you can substitute it minus 1 here, 21 into minus 1 whole power 20, right? Clear? So therefore 2 into minus 1 to the power 20 is what? It is even powers, therefore 21 into 1, right? It is 21. You can see the left hand derivative is not equal to right hand derivative. The function is not differentiable at x equal to minus 1. Clear? The same way you can check the second one. What is that? F dash of 0 plus you can take. 0 plus means you can see limit x goes to 0 plus means 1. Okay, that is will be 1. And f dash of 0 minus you can take, limit x goes to 0 minus. 0 minus means less than 0. What is that? Again 21 into x to the power 20. X to the power 20. So you can apply 0, again 0 here. So right hand derivative is 1, left hand derivative is 0. It is not equal, therefore not differentiable at x equal to 0 also. The same way you have to check third one. F dash of 1 plus you can check. 1 plus means more than 1. That is limit x goes to 0, 1 plus 21 into x to the power 20, that is 21. Clear? When you apply the 1 minus, f dash of 1 minus, that is limit x goes to 1 minus means less than 1, that is 1, it's 1. You can see the right hand derivative is 21 and left hand derivative is 1. Both are not same, therefore the function is not differentiable at minus 1, 0, 1. 3 points is not differentiable. Is continuous everywhere and not differentiable at 3 points, minus 1 and 0, 1, right?